x plus 1 is a factor of this particular expression, then find the value of a and b given 2a minus 3b is equal to 4. First of all, how can we make use of this particular information? The whole funda is that we have to make use of x plus 1 is a factor of this particular expression and then find the value of a and b and so on and so forth. Where do we come across this? Yes, we come across your 9th grade, or if they've flipped around things, then somewhere along your syllabus you would have finished this aspect by now. So what is that we are looking at? We are looking at remainder theorem. Okay. In particular, since they're telling it's a factor, we're looking at factor theorem. So the funda is quite simple. I'll recall remainder theorem first. So they're telling p of x, that is whatever expression we have over here. This particular expression is our p of x. Let me write that. So we have been given the polynomial p of x. Okay, I'll change the color and write it over here. P of x is equal to 2x cube plus ax square plus 2bx plus 1. This is the factor. Not this is a factor. It has a factor of, and g of x is equal to x plus 1. So p of x has, or g of x is the factor of p of x. I think that's much easier to write. G of x is a factor of p of x. Okay, right? What does that mean? That means that g of x can divide p of x with a remainder of 0. Okay, like for example, 2 is a factor of 10. What does this imply? When I divide 2 with 1, the remainder happens to be 0. Okay, that's the whole funda. Now, what does the remainder theorem tell? Where is the remainder theorem? Oh, here. So we can find the remainder when we divide any given polynomial with a linear expression. We can find the remainder by finding the 0 of the expression. Okay, how do you find the 0? I'll be showing that also. Find the 0, substitute it over there, and when you substitute it in p of x, in place of x, if you substitute this particular number or expression or whatever we get, right, that output, on solving whatever we get, that will be the remainder. Now in this case it's already a factor. Because it's a factor, right, because it's a factor, the remainder will be 0. Okay, so I'll explain this again with the question itself. Now, first thing is finding the 0 of, begins with finding the 0 of g of x. How do you find the 0 of g of x? That is, what value will make the output to be 0? That's the question. What is it? X is equal to minus 1. That is the 0 of g of x. Now, what do you do with this information? We're going to substitute, right, x is equal to minus 1 in p of x. So as per, we're making use of remainder theorem. P of x is equal to minus 1 should give us an output of 0. Okay, that is, in place of x, if I put minus 1, the output should be equal to 0. So what we can do is 2 of minus 1 the whole cube plus a into minus 1 the whole square plus 2 into b into minus 1 plus 1 is equal to 0. Okay, I hope you guys understood. What did we do? We found the 0 of g of x, that we substituted in p of x as per the remainder theorem, actually factor theorem to be more precise, as per the factor theorem. The output should be equal to 0, and so we equated it to 0. Okay, this is equal to 0, and now we have to simplify this. So we have, this is minus 2, This is plus a minus 2b plus 1 is equal to 0, and we have a minus 2b is equal to 1, and that would be our equation 1. And the second equation is over there in the question itself. 2a minus 3b is equal to 4. 2a minus 3b is equal to 4. That is equation 2. Now what should we do? Equation 1 and equation 2. So you multiply equation 2 and subtract with, multiply equation 1 with 2 and subtract with equation 2. I hope you guys got that. By now you guys will be used to all of this. So we have, this is 2a minus 4b is equal to 2, and this is 2a minus 3b is equal to 4. Since we are subtracting this, what happens with the signs? This becomes negative, positive, and negative. And we have a line and cut, and we have minus 1b is equal to minus 2. Therefore, b is equal to 2. Okay guys, all this is quite simple. The main funda was over here. See, it's not too much, but yes, this is a very difficult question if you don't know. Obviously, not difficult. You won't be able to do it if you don't know about this factor theorem. Okay, so yeah, this is very important. So level 3 question. See to that you guys put it somewhere wherein you will revise before your exams. Okay, so this is b is equal to 2. Then what else we have? We have to find a, right? We're going to substitute b in equation 1, I guess, which is a minus 2b is equal to 1. So a will be equal to 1 plus 4, which is equal to 5. I think that's the answer, right? We have to figure out a and b. Yeah, find the values of a and b given that. Okay, so finally we'll just write a comma b is equal to, again summarizing the answer will help the teacher to correct the paper easily. That would be equal to 5 comma 2. Okay, right guys, so this is your answer. Again, pause, just go through all this, see to that you copy it in a place wherein you're going to revise. Doesn't matter if you're going to write in your textbook or your notebook also. I'm sure your teachers will not mind. Just tell ma'am it's for revision, they won't mind. So pause, write through everything, and yes, this is part of your syllabus also. I put it in your what do you call, concept map revision sheet. Where is that exactly? I mixed it up. No, this is also part of your syllabus, is it not? Yeah, I mixed it up. Okay, so it's there in your concept map. Please see to that you revise, because they can ask you anything from anywhere. They can ask you cyclic quadrilateral, so on and so forth. Anything from anywhere. Any chapter can be mixed with anything. Okay, yeah, and now you guys can pause and have a look at the answer.